Hello, this is day one of confidence intervals. Give you a second to read the comic. You can pause it, read it. We're going to be talking about TVs today. All right, so I'm going to get rid of the comic and delve into what does a confidence interval look like. There are 4 steps, and we are going to use these 4 steps for lots of things this semester. So this is the problem. There's a company that makes TV wires, and they're supposed to be a certain tension. They know that the population standard deviation is 43 megavolts, or millivolts, sorry. Now, this is not going to happen often where we know the population standard deviation. This is just going to be for today. So this is going to change, but all the other parts will stay the same. They took a sample of size 35 and found out that the sample mean was 306.3 millivolts. And our job is to construct and interpret a 90% confidence interval for the mean tension of TV wires. First step is to give it the correct name. Number 1, is this a mean problem or a proportion problem? Typically, the best way to figure out if it's a mean problem or a proportion problem is to look at the last sentence of the paragraph. It says, construct and interpret interval for the mean. So this is a mean. How many samples did we take? We took 1. In this chapter, it's only 1. So the name. So step 1 is give it a name. It is a 1 sample mean. And this is a confidence interval. Later on in chapter 11 and 12, we're going to do something else. But so this is a 1 sample mean confidence interval. And that's all that step 1 is. Getting the correct, hey, is it a 1 sample or 2? It's a 1 sample. We took 1 sample of size 35. And is it a mean problem or proportion? That's step 1. Step 2 are conditions. This is nothing new. Step 1 is, did they randomly pick the stuff? Okay? So you'd have to read the paragraph and say, oh, yes. So let's say that in this instance, they don't say where they got their 35. You would just write down, we assume a simple random sample. Or you would write down, yes, they randomly selected the TV wires to select them. That's step 1. Where did we get the data from? Step 2 is the normal check. Can I use normal approximations? And the correct answer is yes, because our sample size is big enough. So this is nothing new. We did this last chapter. So you need to write, yes, 35 is greater than 30. It is approximately normal. And you need to write out central limit theorem. Some people on the test did not do that and put CLT. That is wrong. We have to write it out. So by the central limit theorem. I don't care on homework or notes or whatever that you put CLT, but this is what you need. So this is half of it. Half of it is giving it a name, checking the conditions. Now, technically, there's another one that goes with this one. I'm not too concerned about it. I would give you extra credit on a test if you talk about it, and it's the idea of independence. Did testing one TV wire affect testing the next TV wire? Probably not. So, if you just want to write down, assume independence that would be fine. This is not a major one. It is important in real life, but we don't talk about it too much. I'll give you extra credit if you're like, hey, I need to test independence, but this is not major. I won't count you off. So this are the 2 steps out of the 4. And we haven't even gotten to mathy stuff. Step 1, name it. Step 2, conditions. Step 3 is the mathy stuff. Confidence interval. A confidence interval is an estimate plus or minus margin of error. So for a 1 sample mean, our estimate is X bar, and a margin of error consists of 2 parts. It consists of a standard deviation, and how many standard deviations you want to go. So this is how we write it. I'll explain it here momentarily. Z star technically tells us how many standard deviations. And then what is a standard deviation? I would love it if you popped it right out, but it is the population standard deviation divided by the square root of n. So this you will need to memorize. You will need to be able to use this. This is the mathy part. So here we go. Let's explain the parts. What is our estimate? What is our best guess? That is X bar, the sample mean. 306.3. You just copy it. There it is. Now, on your homework, you might actually have to calculate this. Maybe they give you 10 different measurements. I hope you can figure out the sample mean. If they give you 10 measurements, you take those 10 measurements, add them together, and divide by 10. That's how you find a sample mean if they don't actually give you this. Plus or minus, we'll come back to Z star momentarily. The population standard deviation, they have to give that to you. That's 43. And the square root of n, square root of 35. Z star tells us how many standard deviations do we want to go. In this problem, they want a 90% confidence interval. This is where we get Z star from. How in the world do you find Z star for 90%? I'll show you. They're saying, hey, we want the middle 90%, and how many standard deviations away do we go to get the middle 90%? In our calculator, we have a button that if you know the percent to the left, you type that in and it gives you the z-score. Now, is there 90% to the left here? No. 90% from here to here. That means that there's 5% here and 5% here. So what percent is to the left? 95. We're going to use our calculator now to figure out what the z-score is. So you want to turn on your calculator. We're going to go to second distributions. We're going to go to number 3, and we're going to type in 0.95, 0.95, and the z-score turned out to be 1.64. 1.64. So z-star turns out to be 1.64. And we'll have time to review this, and you can rewatch this video, and you can ask me questions later. But typically, this is the hardest part. Now, using our calculator, we can finish this up. 306.3 stays the same, plus or minus 43 divided by the square root of 35 times 1.64. The margin of error is 11.92. 306.3 minus 11.92 is 294.38, comma, 306.3 plus 11.92, 318.22. So this is my confidence interval, 294 to 318. Step 3 takes a little more work. That's the mathy part. Step 4 is called the interpretation. Interpretation. And here it goes. We are 90% confident that, and then what are we talking about? We're talking about the mean. We're guessing and making a prediction about the actual population mean. So you can write the word population mean, or you can say true. I'm going to use the word true. If you want to say population mean, that's fine. We are 90% confident that the true mean, and we have to use context, of tension on TV wire is between, let's use the correct numbers, 294.38, 294.38, and 318.22, 318.22, and then we have units. I think it was millivolts. So that is the interpretation. That is everything on confidence intervals for a one sample mean. Rewatch it. Ask other people. Do not come to me and say, I know nothing. I know you can do something. You have the rest of the period to do all the work. Please make sure you ask questions. Try something, and I will be back later. I think I have a joke. Here's the joke. What happens if you drop your iPhone and iPad in the water? They sink. Have a good day.